Hey everyone! In this video, we're going to look at some redox reactions and see if we can determine what's being oxidized and what's being reduced. So the first thing you might ask is, what is a redox reaction? Well, a redox is just a mashup of reduction and oxidation. Alright, well that's a start, but what's reduction and oxidation? Well, an oxidation is any time we do a reaction and a substance loses electrons. So in an oxidation, something in the process of going from being a reactant to a product loses electrons. And a reduction, despite everything that common sense would say, is actually something that gains electrons. And that's going to make more sense later why a reduction is a gain of electrons, but for now, you're just going to have to accept that, and we'll get into that later. There's actually a little mnemonic device to help with this that I use. It's called oil rig. And we say oil rig because OIL, oxidation, is losing, and rig, reduction, is gaining. Maybe that'll help you. Maybe you have some other way that you'd like to remember it, but I find that's a helpful little device. So we're going to start off and write out a chemical reaction where we have zinc solid that's placed in a solution of iron 2 chloride. And that's aqueous, so it's dissolved in water. And it produces iron metal plus a zinc chloride solution. To help us out with this, we're first going to dissociate our aqueous ionic compounds, which means we're going to dissolve them and see what they look like as little ions. So this is dissociation. What do they look like when they're dissolved? We still have a zinc solid, but in that water solution, we're going to have our iron 2 plus cation, as well as 2 negative chloride anions, and on our product side we are still going to have our iron metal, but we're going to have a zinc cation and 2 chloride anions. And I'm just going to scroll this up to help out, and that's our dissociation. In this dissociation, we can see that there's actually something that's on both the left and the right that we can cancel out. In this case, those chloride anions. We can cancel those out because the chloride, that's called a spectator ion. So a spectator ion does not actually participate in the reaction. It's something that we can cancel. It's there on the left. It's there on the right. It didn't do anything. We don't need it. This produces a net Ionic equation that is our zinc solid plus iron 2 plus aqueous turns into solid iron metal plus some dissolved zinc cation. Once you have this net ionic equation, now we have the ability to determine what has been oxidized and what has been reduced. Let's begin by looking at this zinc. The zinc over here as a metal is neutral. On the right-hand side, it is a charge of +2. In order to gain a charge of +2, it had to have lost negative charges, which means it lost 2 electrons. Oxidation is losing. Zinc lost electrons. This has been oxidized. Our iron, on the other hand, in order to go from a 2 plus charge to a neutral charge, it had to have had -2 added to it, which means it actually gained 2 electrons. The iron was reduced. the iron was reduced. I'm going to scroll up, and we're going to actually write this as two half reactions. So, half reactions. One of our half reactions is the zinc solid becomes the zinc 2 plus aqueous plus 2 electrons. This is our oxidation half reaction. So this is our oxidation half reaction. Our other half reaction is that we had an iron 2 plus aqueous, and it gained 2 electrons. So it's going to turn into iron solid. This is considered our reduction half reaction. So we can see, we can look at this. Zinc got oxidized, iron got reduced. Let's go ahead and do a second little example here. We're going to move that up. And this time we are going to mix copper solid into a solution of mercury 2 nitrate. And that's all dissolved, so that's aqueous. And this is going to produce copper 2 nitrate, which is aqueous, and some mercury metal. Again, we can write out that dissociated equation where we end up with a copper solid plus our mercury ion plus we have 2 nitrate ions. Hopefully you can see where this is going right now. Hopefully you can see where this is going, because once again we are going to end up with a spectator ion that we are going to cancel. In this case, our spectator ion is going to be this nitrate. We have 2 nitrates on the left. We have 2 nitrates on the right. We can go ahead and cancel those out because that 2NO3 minus is a spectator ion. It is not actually part of this reaction. We can cancel that out. This leaves us with our net ionic equation. Net ionic equation of copper solid plus our mercury cation that's dissolved in water. And this is going to produce our copper 2 plus aqueous and our mercury metal. Great! We have a net ionic equation. Now let's figure out who's gaining electrons and who's losing electrons. Our copper went from being copper 0 to copper 2 plus. Because it gained a positive charge, you can't gain protons, so the only way to gain a positive charge is if you lose 2 electrons. That means our copper, oxidation is losing, was oxidized. Our mercury instead went from 2 plus to 0. The only way that can happen is if you gained 2 negative charges. So it gained 2 electrons and it was reduced. Let's write out those half reactions. Our half reactions in this case are a copper solid becomes copper 2 plus aqueous plus 2 electrons. If you're ever unsure on which side to put the electrons, remember that both sides have to be neutrally charged, or both sides have to have the same charge. So since the left is 0, the right must also be 0. A plus 2, a minus 2, that gives us 0 on both sides. This is our oxidation half reaction. Our reduction half reaction is our Mercury 2 plus aqueous plus our 2 electrons. Again, I know that I have to make this neutral, so I have the 2 plus, so my 2 electrons go on that side, and this becomes mercury metal. And this is our reduction half reaction. And this is a little start to how you recognize which parts of a redox reaction are being oxidized and which ones are being reduced.